Okay, we're going to be going over this covalent practice. So you should have a sheet that looks very similar to this. And we're just going to do a bunch of problems as practice. So the first one that we're going to look at is N2. So if you remember, this is going to be nitrogen. Nitrogen is also one of the 7 diatomic molecules. So what that means is when it appears in nature, it's always going to be paired with a second one of itself. So for this activity and for all bonding, we are looking at valence electrons. So remember, valence electrons are electrons in your outer shell. If you look at a periodic table, nitrogen is going to have 5 valence electrons. Okay, so if we're looking at the normal Lewis structure of nitrogen, it would be N, 1, 2, 3, 4, and then you can add that extra dot anywhere, so we'll just throw it in there. So for this activity, we're trying to bond the different molecules together in their Lewis structure. So what I like to do is I like to write out all the elements that we have. So we have nitrogen twice, and then by no means do you have to do this, but this is just what works best for me. I go with what they have versus what they want. So nitrogen, we said, has 5 valence electrons, so I'm going to put a 5 here. There's a second one, so I'm going to put a 5 there as well. And the goal is 8, with the exception of a few. Goal is 8 valence electrons in your outer shell. So we have 8 here, 8 here. So what you're going to do next is you're going to add these all up if you remember from the PowerPoint. So what it has 10 valence electrons, but it wants 16. Okay? Your want is also going to be your final, and your has is your current. So if you remember from the PowerPoint, you're going to take your final, subtract it from your current, and that whole thing is going to be divided by 2. So I'm going to take my 16, I'm going to subtract 10 from it. That whole thing is going to be divided by 2. 16 minus 10 is going to be 6. Divided by 2, it's going to be 3. So there are 3 covalent bonds in N2. So for my Lewis structure, I drew one of them out, but I'm going to draw them both out separately. Sorry about that. Okay, so there's 3 bonds, but there's only 2 atoms here. So what that's going to be is it's going to be all the bonds are going to happen on one side. Remember, with covalent, you are sharing electrons. So when we're sharing electrons, think what's mine is yours, what's yours is mine. So we're going to count those numbers that those electrons that they're sharing as part of the valence electrons. So we have 3 covalent bonds, and we only have 2 atoms. So like I said, they're going to be on the same side. So what I'm going to do is I'm going to configure this. So I'm going to do nitrogen next to one another. We said there's going to be 3 bonds on one side. So 1, 2, 3 on that. 1, 2, 3. And with covalent bonding, they show that they're sharing by having this bar connecting them. Okay? So if I'm counting my valence electrons, if I'm looking at this nitrogen, I have 1, 2, 3, 4, 5, 6. Okay, so I have 6 for this nitrogen. I'm still missing 2. So you're just going to add 2 electrons wherever you'd like. So I'm going to add one here, and I'll add one here. We're going to do the same thing for the other nitrogen. So we still have 6 from here. So you're just going to add the other 2 from or on another side. So 1, 2. And the reason you do that is because, remember, nitrogen had 5 valence electrons. So even before we added this bar, it had 1, 2, it had 1, 2, 3, 4, 5, and then this became the 6th, the 7th, and the 8th. Okay, this one's a little bit unique because it has those 3 bonds on the one side. So really starting off with a bang. Okay, we're gonna keep doing some practice. Let's add a new page. Oh, let's just clear page. Okay, So our next molecule that we're working on is H2O. So this one was an example in the PowerPoint, but we'll do it as well. So I set up my little table, has versus wants. We have hydrogen, hydrogen, and 1 oxygen. So remember, hydrogen is a special case. Its atomic number is 1, so there's only 1 electron, and it only wants 2. So remember, hydrogen is in that 1s block where it only can take 2 electrons. This one is the same. And then oxygen has 6 electrons, wants 8. So we're going to add that up. So 6 plus 2 is going to give us 8. 8 plus 4 is going to give us 12. 12 minus 8 is going to give us 4. Divided by 2, this molecule is going to have 2 bonds. So when you're setting it up, this one has 3 molecules, and you are always going to have to put 1 in the center. You're going to want to put the 1 in the center that has the most open spaces. So hydrogen can take 2 electrons in order to get to 8, while the hydrogen can only take 1. Therefore, oxygen is going to be in the center. So we have our oxygen. It has 6 electrons, so 1, 2, 3, 4, 5, 6, and then you're just going to add a hydrogen to each end. So hydrogen, those are going to connect, those are going to connect, and then you just add your bar. Okay, that one was simple enough. Let's do the next one. So the next one is CH4. So here you have 1 carbon and 4 hydrogens. So I like to write them out. For the hydrogens, because there's so many of them, instead of writing them out, I'm just going to multiply them, but know that what I'm doing is because there's 4 of them. So carbon has 4, wants 8. Hydrogen has 1, but I'm multiplying it by 4, so it's going to be 4. Hydrogen wants 2, but I'm multiplying it by 4, so I have 8. 4 plus 4 is going to be 8. 8 plus 8 is going to be 16. 16 minus 8 over 2. Going to be 8 over 2, which is going to give us 4 covalent bonds. Okay, so like I said last time, you're going to look for the atom that has the most available spots open, and that's going to be carbon. So carbon is going to be in the center. I'm going to write out the atomic structure, and I have 4 hydrogens left, and each hydrogen only needs 1 electron, so we're just going to plug a hydrogen at each end of this carbon. And just link them up. Simple enough. Okay. So let's do CH3Cl. So we have carbon, we have the 3 hydrogens, so I'm going to do the same thing I just did, and we have a chlorine. Carbon has 4, wants 8. There are 3 hydrogen, has 3 electrons, wants 6 because I multiplied it by 3. Chlorine is 7, wants 8. Add those up. 7 plus 3 is 10, plus 4 is 14. 8 plus 8 is 16, plus 6 is going to be 22. 8 plus 8 is 16, 22. 22 minus 14. All of this is going to be divided by 8. 22 minus 14, I'm not a math teacher. It's going to be 8. 8. Oh, this, oh. Be 8 over 2, so there are 4 covalent bonds here. So, again, I look at which atoms I have to work with. Carbon is the one that has the most spaces available. Hydrogen can only take 1, chlorine can only take 1. So my carbon is in the center. I'm going to work with the chlorine first because the chlorine is the biggest one. So my normal chlorine Lewis structure is going to look like this. So easy enough, I got an empty space here for a electron, and I have a nice electron right there waiting for it. So we're just going to set it up. Here we go. So chlorine had 7 originally, and then this linking up with this carbon gave it 8, so this one is good. And then I have 3 hydrogens, and I'm going to do very similar to the last one and just plug them up at the end of this carbon. Link it up, link it up, link it up. So that's our molecule. So if you want to check it, chlorine had 8, hydrogen, this one has 2, check. This one has 2, check. This one has 2, check. And then the carbon, I have 1, 2, 3, 4, 5, 6, 7, 8. So this one is also good to go. Let's look at COCl2 has versus wants. So we have carbon, we have oxygen, we have 2 chlorines. Carbon has 4, wants 8, oxygen has 6, wants 8, chlorine 7, they all want 8. Add them up. 7 plus 7 is 14, plus 6 is 20, plus 4 is 24. 8 times 4 is 32. 32 minus 24 is going to be 8 over 2. This one has 4 bonds. Okay, so let's look again. We got, I'm going to just draw out the structure because this one's a little bit more complicated because it's not as clear as knowing that hydrogens are, because hydrogens only have 1 electron, it was easy to determine that they were going off. They were going to be at the end. But because you have a little bit more space with the oxygens, I'm just going to draw out all of their Lewis structures. So carbon, we said, has 4. Oxygen has 6. And then chlorine, I'm only going to draw it once because I don't feel like drawing it twice. Chlorine had 7. So with this, it would be, the middle element would be between carbon and oxygen. I'm going to put carbon anyways, and then if I need to like reconfigure, I will. So, oh wait, this is chlorine. Okay, so chlorine, oh my goodness, not chlorine, carbon. Okay, so I'm going to put carbon at the 7er. Oh my goodness, it is too early for this. So carbon, 1, 2, 3, 4. We said chlorine only needs 1, so I'm just going to tack it on to one end. Okay, so this one. Okay, so this one has 8. We're good to go. But I got 1 more chlorine, so I'm going to do it to the other side as well. Okay, so this chlorine is also done. Now I have this oxygen where I have 2 open spots, and I also have 2 open spots in the carbon. So what I'm going to do is going to be very similar to that first element where I put it all on one side. So I'm going to remove this one. I'm going to move it up here, and then I'm going to add a double bond to this oxygen. So oxygen, it's going to be 1, 2, okay, so we're tacking it on. So this is giving me 4, 5, 6, 7, 8, and then carbon has 1, 2, 3, 4, 5, 6, 7, 8 because of all the ones that are attached to other other atoms. So that one's good too. Okay. Trying to see if there's any other ones that might be difficult. Let's try, if you look on the back of your worksheet, you have one that says CH2Fe, or I'm sorry, F2. So this is gonna be the last one we do together, and then the other ones could be practice for you. So has versus wants. So we have carbon, we have hydrogen, and we have fluorine. So carbon has 4, wants 8, hydrogen has 1, wants 2, same thing. Fluorine has 7, wants 8, 7, wants 8. Add it up. 7 plus 7 is 14, plus 4 is 18, 19, 20. 8 and 2 make 10, 8 and 2 make 10, so that's 20, 28. 28 minus 20 is going to give us 8 over 2. We got 4 bonds here. Okay, carbon, it's going to be in the center again because it has the most spaces available based on our table. So carbon, we're going to attach 1 electron in each end and move around as needed. So fluorine has 7, only needs 1, so I'm going to just add it to one side. 1, 2, 3, 4, 5, 6, 7. Attaching this is going to make it 8. Fluorine's good. I have another fluorine, so I'm going to do it on the opposite side. It doesn't matter where you put them. You can put them on the top if you prefer, on the bottom. As long as it matches like the electron numbers, you're good to go. This one's 8. Then you got 2 hydrogens that I'm going to tack on at the end. There you go. This has 2, this has 2, carbon has 8. Okay, hopefully this was helpful. If you need help, please